Hey everyone, my name is Lokesh. So in this video, we will discuss about different deployment strategies. So I will divide this video into two parts. So in the first part, we will discuss what is deployment and what are the different challenges in deployment, right? And also what are the different methods that a deployment can happen. And in the second part, we will discuss about different deployment patterns. Right? So let's discuss about what is deployment first, right? So deployment is, in simple words, is just nothing but running your new version of code, right? In the same set of servers, right? So if you have some servers, right, it can be same or different servers, but running your new version of code in the same or different set of servers, right? That's what the deployment is, right? We basically ship the features or code incrementally, right? So like every 2 weeks or every month, right? Like whenever or like if there are any bugs, right? So we need to deploy the changes, right? So and also so the main goal of that would be right to enhance the user experience, right? Obviously. So that's the main goal of deployment, right? So, and let's come to the other part, right? How deployments happen, right? So how I would say, if I put it in this way, in software engineering, right? How the way of doing deployments evolved over the years, right? So, so when I started my career in 2015, I have seen I have seen people doing deployments in Ansible playbooks, right? But before that, so when Ansible playbooks were not there, people used to do the manual deployments, right? So when we say manual, you just log into the server and pull the code from Git and restart your application server, restart your reverse proxy such as Nginx or Apache, and that's all done, right? Then the Ansible playbooks came, right? So they basically automated this process, right? So so a playbook is nothing but a series of steps, right? A sequential steps. So where we just define whatever we do manually, we just define it there as steps, right? And we when we write the commands for each of the step, right? So that's what the Ansible had solved, right? And then after that, so there came the containerization, right? So, like, so basically, like what, so containerization, so solve the, problem of optimizing a single machine, right? So be it virtualization, initially the virtualization, came into picture, right? So with VirtualBox, with like different software, like which VirtualBox, etc. So they allowed us to run, different operating systems in the same machine, right? So by sharing the resources of that machine, right? So and then after that, the containers came, right? Which is Docker, which optimized this virtualization, right? In a completely different way, and before containerization, so there is another, like technology, I would say, approach called virtualization, right? So like we would have heard the terms virtual box, right? So where we can run the different operating systems in another operating system, right? So by sharing the same resources of that host machine, right? So even like VMware, I mean, so this virtual box was popular, right? So there are there are tools like Vagrant, which allowed us to automate this deployment, right? So and after virtualization, then the containerization came, right? So containerization completely came up with a new, I would say, a new approach, right? And it actually revolutionized the entire deployment process, right? So basically, with containerization, we can run an isolated, I would say, isolated operating system, in a very optimized way, right? So that's what the containerization is, right? And then after that, we got containerization within the orchestrator, which we are at currently, right? So orchestrator is nothing but if we relate that to a real world example, right? So in music orchestras, right, we used to see one person guiding the other people, right? And that person is called orchestrator, right? Similarly here, the orchestrator, such as Kubernetes, will do the role of that orchestrating, like meaning how different containers should compose each other to run effectively, right? So that's what the Kubernetes gives us, right? So yeah, so these are the different methods how we can do the deployments. Okay, now let's see what are some of the challenges in doing a deployment, right? So one very important thing to consider here is the database migrations, right? So it's very common, and it's very normal to have a database for an backend service, right? So where the backend service store the state there, right? And so when you are deploying different versions, right, the changes to the database should be backward compatible, right? So so or else there will be downtimes that can occur, right? So we should be, for example, let's say you have made some changes to your database table, right? And then let's say you deployed your new changes, right? And then let's say if those new code changes are failed, like due to some bug, right? And you need, let's say, some 1 hour to fix that issue, right? And then, like, if your database changes are not backward compatible, right, you cannot run your code with your old version of code also, right? That means you need to you know you need to mandatorily fix that bugs in the code to run it, right? Which means like there is a downtime, right, until you fix that. So that's how the impact of database migrations, right? So there are different approaches how we can make the database migrations backward compatible, right? So this is how I follow, right? This is how I approach. So I make a table, right? So so adding column, removing column, modify renaming column, and dropping it complete table, right? So these are different operations, right? And these are different queries on the table: select, update, create, delete, like correct, basically, right? And now I have the current version and the new version, right? And I just need to think about how I can make this migration, or make this like whatever the operations that I'm doing here, right, to be safe and backward compatible, right? So I think if I go and explain that, I think maybe I'll be diverting, or going into a different topic. So maybe I think I'll create a different video on that, right? So yeah, we'll see that. But yeah, but to summarize, like, the database migrations are very important, and we must take care to make them backward compatible, right? Okay. So now comes the stateful applications. So what are stateful applications? Meaning your application is having some state, right, which is stored in its local machine, right? So for example, let's say you have an app server running in your server, and let's say if it uses a message broker or DB, right, which is internal to that machine, right? Which is not anywhere, which is internal to that, right? So like, you may think like, what so how it can affect the deployment, right? So uh, let's say that you're running your application in a server, right? And let's say you want to deploy that in a new server. Let's say there are some issue with that, right? And you want to migrate to that to a new server, right? And now the thing is, so this server is using local state. So let's say it's using some database, and it has, let's say, 2 GB of data, right? Now the challenge is you need to move that entire data to the another machine, right? So that's a challenge, and that may incur some downtime also, right? So that's the problem with the stateful applications. So so in real world, right? So in the modern systems, I think having stateful applications is very very rare. We are working, we are going towards the stateless applications, because with the new Kubernetes or the Docker, etc. Right? So it's not viable to maintain the state in the local machine, right? Because if you dockerized your app, and if you're running in Kubernetes, right, every time a new container will be created, right, and that container will not get the state from your previous version, right. So yeah, so I think it's always better to have stateless applications. And the next one is backward compatibility of code changes, right? So I think this is very, very, very much related to the database migrations, right? So as with your database migrations, right? So whatever the code changes that you're doing should be backward compatible, right? So so let's say, not only database, right? Let's say if you are, I mean, if there are any other changes in the code, like API changes or anything, right? So always it's better to have the backward compatibility, right? And the other one is downtime impact on business. So see, so the thing is, the deployments are hard, okay? So, and there are chances that deployments can go wrong, right? And we need to be prepared for the worst, right? So, so let's say let's say that you're deploying something, and something went wrong, and and your whole business is down, right? And it's impacting your revenue, right? So so that's why, like, it's very important to choose the deployment time, right, when you should deploy these changes, right? So that's very important. And ideally, like, the general practice is, and is to deploy in the non-business hours generally, right? I mean, that's how everyone do, right? Yeah, but basically, like, when we are deploying anything, we just have to keep the impact on business in mind, right? So this is very important, right? So now let's come to the part two. So in part two, we will discuss about different deployment patterns, right? So the first one is in place or recreate deployment, right? So, so this deployment is basically very basic, very naive approach, right? So let's say you have some servers where your code is running, right? And you want to deploy the new changes, right? So the very naive way would be, you will be logging into each machine sequentially, and you'll be doing the deployment steps, right? Pulling the code, and restarting your application server, restarting your Nginx, etc. Right? And then you'll be doing that for all of your machines, right? Simple, very very simple thing, right? So now, so what are the pros of this approach, right? So one pro is it's very cost effective, I would say, right? Because you don't need to maintain any separate set of nodes, right? So that's why it's really cost effective, right? And the cons, right? So there can be a possibility of huge downtime, right? So let's say, like, while you are doing those changes to each of your server, right? And and your service may get down, right? So let's say you have only one server, right? And while you're deploying that new version, right? You may actually have some few seconds of downtime, right? It can be possible, right? uh, and then rollouts are problematic, right? So so rolling out, basically, let's say if there is some problem with the new version, right, to basically roll out those changes, right, it's very hard, right? So because you need to revert all of your code changes, or you need to revert that pull request maybe, right, or manually undo all your code changes, and then you need to deploy, right? And this might take time, right? So so that's why it's not a very safe approach, right? Like this can be used, like, when when there is less business impact on your code, right? And it's okay to have downtimes, right? So basically, initially you can start with this, right, when your traffic is very low. Now let's discuss about Canary deployment, right? So the name Canary came from a bird name, no, bird called canary, right? So So here is the story, right? So in 18th century, the people used to work in the caves, right, or to basically get that oil. So usually in the caves the temperatures are very high, right, and the oxygen levels are very low. So then then the people used to take this bird canary into that caves, and if they find that bird is alive, then that means it's safe to go inside, and if not, it's not safe to go inside, right? So basically they used to test whether it is safe to go or not, right? So I think you may already got like what canary deployment is, right? So just like that canary bird, we basically deploy our code to few machines, right? Let's say 2% of your machines, and divert the traffic to those new machines, right? And if there are no problems, then we will roll out to all 100% of the machines, and do a complete rollout, right? And if there are any problems with the deployment, we will basically roll back that deployment, right? It's very simple. So let's talk about the pros and cons of this approach, right? So the pros would be, so there is no need of maintaining multiple sets of servers, right? So you can basically do this on the same set of nodes, right? So I mean, of course, I mean in this figure I depicted two sets, but yeah, I mean this basically is one set, So what I meant is like you basically deploy to one machine, and then after that we'll deploy to all the machines, right? So, and it is cost effective, right? Yeah, of course, it is cost effective because you're not you're only maintaining one set of nodes, right? So that is about that. And again, like when so let's discuss about cons. So when it comes to cons, so I think one problem is again, the backward compatibility, right? So your code changes should be backward compatible, and your database changes should be backward compatible. It's a thumb rule, okay? For any deployment strategy, these are mandatory, right? Because you never know, right? So you may have to roll back your deployment to the old version, right? So always make your code changes and database changes work for n-1 versions, right? So now let's talk about blue-green deployment, right? So this strategy is very popular. I think it is very widely used. So in this one, as the name suggests, right, there are two sets of servers that will be maintained, right? So let's say one is called staging, and then one another is called production, or one, let's say one we call it blue, or one we call it green, right? Whatever the names is. So the idea is this, right? So that your load balancer points to your current set of nodes that is running your code, right? So this is your current version, right? And it is in the green color, right? So so while your load balancer pointed to this green, right? You basically you basically deploy your code to the another set of nodes, right? Which is called, let's say, version U, right? So when the code is deployed to new servers, and you'll see the metrics, right, the health checks and everything, right? And if all are fine and it's working, so then you basically do a switch at the load balancer level by switching from green to the current version or the new version, basically, right? So you basically switch from green to blue, and you just change this color to green. I mean, see, this entire thing happens logically, right? So, and which means this is your current version that's running, right? Simple. So this is how it works, right? So, and let's discuss about the pros and cons of this, right? So, one pro would be no or less downtime in this, right? Because there's a very quick switch, right? And at the load balancer level, right? So basically, so whatever the load balancer you have, right, you will be given that in your domain records, right? So which means there's no need of updating that, right? And it's just at the load balancer level configuration, and it would be very, very fast, right? So which means very less or no downtime, and rollbacks are very easy, right? So because we we will not kill the the older one, right? Maybe we'll keep it for some time, right? And when we are confident and when the 100% of traffic is redirected to the new one, so then we will maybe kill the older one, right? So in this case, the rollbacks are very easy, right? So because you have the you have the old fleet of your servers running, right? So it's just a matter of quick switch at the load balancer level, right? So yeah, so that's one thing. Uh, and like when so let's when it comes to cons, right? So the con would be you need to maintain two sets of nodes, right? So which is basically cost effective. I mean, not so cost effective, require more cost, right? And you may need to maintain two database instances, right? I mean, so some people maintain. I mean, some teams maintain. Say staging and production. They say, right? But not required if your database changes and your code changes are backward compatible. So so as I said, that thumb rule, right? Backward compatibility is very important in deployments. So that's one thing. Yeah. So yeah, so that's all about this blue green deployment, right? Very simple, nothing else. Very simple, right? Yeah, and and let's see the ramped or rolling update, right? So this rolling update is the default mechanism, for Kubernetes, right? So let's see how this works, right? So it's very simple, I mean, so you basically, like, let's say you have your current set of nodes that are running, right? So when your new version of code needs to be deployed, right? It will be deployed in a separate set, right? So once that is deployed and the health checks are fine, and it is completely deployed up and running, then we basically remove one machine from the old fleet, and and we will keep running the new one, right? And similarly we will do it for the all the machines, right? And so and then in the end 100 when the 100% of traffic transfer to set B, so it means that our deployment is completed, right? So and in this case it's very important to point your load balancer to two sets of servers, right? So if I mean, of course, load balancers are intelligent, and they have the capability to redirect to the the machines which are healthy, right? So you don't need to worry about downtime much here. So yeah, so that's about this, right? So and let's see the pros, right? So less downtime, right? Similar to what we have seen in blue green, right? Very less downtime. The deployments are hard here, right? Because you'll be killing the older one when the new one is up and running, right? So it's a little hard here, right? And let's see the cons here, right? So two sets of nodes are required here, right? So now let's see the A/B testing, right? So so A/B testing is primarily used for the functional testing or user acceptance testing, right? So to gather feedback from the users. Right? So basically we divide users into set A and set B, right? And how the traffic gets divided is from the load balancer level, right? So meaning when the request comes, right? So it will have a cookie or header, right? So we will basically add that custom header, and we will need to add that logic in load balancer, or basically not, if not in load balancer, your API gateway maybe, right? So you add that logic that based on that you redirect the traffic to set A or to set B, right? So and also in set A and set B there will be set of servers running multiple versions of the code, right? So set A may be running previous version, or set B might be running another version, right? So both can be running different versions, and then based on the based on the user acceptability, right? So the team will make the decision which one to keep, right? And then they'll keep one, and then they'll destroy the other set, right? That's how this works. So I think, yeah, that's all for this one, guys. So let's meet in the next video, right? Until then, bye. Okay, yeah, see you.